Hi, I'm Laszlo from Prezi. I'm a Canadian guy working in Budapest. How many people here know Prezi? Okay, that's good. It's this presentation tool that I'm using, and it's written in ActionScript. It's a Flash application, and I'm the tech lead of the JavaScript team at Prezi, and we're rewriting the application, basically with JavaScript. So I'm a front-end developer. I love mostly UI development. It's always been my passion. So when I came to Prezi, I was, even though I applied to be a Python developer, I started working on ActionScript. Nobody wants to be an ActionScript developer, but that was my passion. But it was one team. A year ago, it was one team with 15 developers and a big monolithic app. It was written in ActionScript and Hax. Does anybody here know Hax? It's a kind of obscure language from France that compiles to ActionScript and JavaScript. So we had some legacy code written in Hax which we could reuse compiling to JavaScript. But we don't want to use it forever. We want to be able to use TypeScript, vanilla JavaScript, and others. And now we have 4 teams, and we have 3 to 6 developers each, which I think is a much better size. I don't want to have 15 developers in one giant team working on one monolithic code base. So we're rewriting the application, but we don't want to repeat the same mistakes. We want to avoid these large teams. We want to avoid getting stuck using one language or one programming paradigm. And we want to avoid development bottlenecks, so we need a better architecture. And as a front-end guy, I'm really jealous of back-end developers because they can choose whatever programming language they want. They can have a small team, just make a nice REST API, and then anyone else can use their service. They can, in Prezi, we do the website in Python, we do back-end services in Scala, we're using some Netflix APIs. That's on a JVM. You could also do it in Node.js if you're a JavaScript person. And I put Perl there because one of the biggest companies that uses this architecture is Amazon. And they do their stuff in C++ and Java, but they still have some services written in Perl. And probably they started with Perl, but they didn't get stuck using Perl forever because they could replace each component one at a time using a new technology. And I'm really jealous of that because if you have a big ActionScript application, you don't want to be stuck writing an ActionScript forever. Same thing with JavaScript. So this is the component model. This is what you often hear referred to as service-oriented architecture. It means that you have a bunch of different servers and your application will communicate with each of them individually. The main server here, for example, Prezi.com, provides you with a token, which you can use to access your Prezis on the storage server. Same thing with the media and the other metadata, and there's no bottleneck. This is kind of similar to the old CGI model, where you had a website, web servers, which you could add many of to scale your website, but you still kept all your data in one database, in one central location. And this was easy to scale because the performance was usually on the web server part and not the database part. But as data got bigger and bigger, people have moved to this model because there's no single point of failure, there's no bottleneck in the system. So backend developers already did this. Not because they wanted to, but because they had to. They had too much data, too many different services, and they had to split it up into different machines. But this wasn't the only advantage to doing it this way. It also gave them the opportunity to use different technologies and replace each service one at a time without changing their whole system. So that's what I want for JavaScript development. So I already mentioned why, but the main points are better separation, so the teams can be more independent, at least semi-independent, agile, and define their own goals and strategies. strategy, and you can change technologies without affecting the whole system or company. And this is really important as your company grows. Prezi is now 200 people, and the backend teams are doing fine. They just follow this model. They have about 5 developers on each team, and some use Python, some use Scala, some use Java, and they don't have so many conflicts between the teams. Whereas on the front end, we have to coordinate a lot more and write on one code base. And of course, we don't always want to do everything in JavaScript. We like static type checking, so we want to use TypeScript and hacks when we need to. And this might be controversial for a lot of JavaScript developers. I don't think that JavaScript is the best tool for all tasks. I think there are different programming paradigms, and I would like to be able to use those in my application when it's the best tool for the job. I'll talk more about that later. So how can we do this? We could do it, if you're writing a desktop application, we could do it in a multi-process way. This is Corba style. Does anybody remember Corba from the 90s? That was really horrible, the worst thing that ever happened to client-side development. And we could also just copy the backend developers and just make REST APIs between our JavaScript modules. But that seems like a lot of unnecessary overhead and basically a waste of have to marshal everything into some format and marshal it back out. So, we want to keep it simple, but we want something that brings us these same kind of advantages. So what we're doing at Prezi is for each module, we're writing a module definition file. It has a set of static methods, each of which can return JavaScript primitives, or they can return an interface, which has more methods on it that return primitives or other interfaces. This is just like you would write in Java or C++ or any language with interfaces. It encourages, but you have to write it in a separate file. That's not just part of your implementation. So it encourages you to keep it small and to document each method that you expose. It doesn't enforce good design, it just enables it. So you still have to take care to not make spaghetti code and not have a really entangled design in your application. But if you do have a good application, you know how to structure your application into separate modules, it enables you to do that easily. And it can be used by any compiled to JavaScript language. So this is what it looks like. You have a namespace and your module name, and then below that you have a list of static methods, and then you have a list of interfaces, enums, whatever constants that you want to define. This pattern is a factory pattern, so you can do a whole bunch of different patterns here. You could just expose all the methods from your application, just like a really big C++ header file, but that would defeat purpose, it wouldn't gain anything. So this specific pattern that we're using is a factory where you give it a div and it creates a UI module which then renders the UI inside that div, and you can pass events into it using the methods on that interface. So the languages that we support right now are TypeScript and hacks. So the module definition is parsed, and we generate interfaces. And if you know TypeScript interface is just a compile time thing to check that you use the API correctly, you didn't make any typos, and then it just disappears, and TypeScript will generate the JavaScript for you. You can also use it from JavaScript and CoffeeScript, and the module definition is your documentation. And this, I didn't put it in this example, but you can put documentation in line here, and it will auto-generate the HTML documentation for you. So this encourages people who, if you're a team and you're providing a service to some other team in the company, it encourages you to create a nice public API and document it well, even if the people who use your API are not going to use any type checking. And the other thing it does is it makes everything else private. So if you're using JavaScript, you can't just rely on private APIs because the whole module is going to be obfuscated, and it knows the symbols that are publicly exposed, and it will preserve those in your JavaScript. So this looks kind of like we just did Java interfaces or C++ interfaces, but we just did it in a more generic way. But it's not just that, because this is not just about object-oriented programming. I mentioned earlier that I don't think JavaScript is the best tool for the job, and I would like to be able to use different programming paradigms not for my whole application, but just a specific part where it's the best tool for the job. So my example is Elm. This is a compiled to JavaScript language that has a Haskell-like syntax. It's a purely functional programming language, and it uses functional reactive programming to generate your DOM with CSS, and you can also generate canvas animations, things like that. So it's like Haskell, but by default it does UI. It's not just for people proving mathematical theorems. So this example that I showed you, you might have noticed that in the interface all of the methods return void. So it's not actually a object-oriented style. This is a message passing style. So the user joined. When a user joins, we pass in the user ID and the name and the URL of the avatar, and this will send a message into the reactive system that this a user has joined. Same as user leave, and setPresenter does the same thing, except instead of a event, you can think of it as it actually changes a property, but it's the same thing. It's a value that changed in the reactive system, and then the UI will be regenerated to reflect the changes. And the last one is an event coming out of the reactive system. So you give it a callback, and it tells you when the user wants to start presenting. So we take this code and we generate some type definitions in Elm. Elm is kind of like Haskell, so it's strictly typed. And then you can import these signals, which are values that change over time, and you can use them in your functional reactive programming. But we are switching from an object-oriented paradigm to a functional reactive programming paradigm. So the people who use this API want to use it like it's an object-oriented API, and the people who implement it want to use it like it's functional. So we need to generate some wrapper code. So from this, we can generate this JavaScript. So this JavaScript, remember, there's a factory function which takes a div and creates the Elm module, and then it returns an object which has these methods. And when some object-oriented style code calls one of these methods, it sends an event into the reactive system. And we start presenting, it hooks a callback to get values out of the reactive system. And so then we take the rest of the Elm code that looks like this. If you know Haskell, you might be able to read it. And then it generates this. So this is the div, this black part, and this is the user list UI. We have another module, which is written in TypeScript or JavaScript, I don't really care which, but it does the network communication, and when a new user joins, then it tells the UI that the user has joined. And when the user leaves, the same. And then when you click Start Presenting, it gets a callback that I want to be the presenter in this Prezi. And this works really, really well because there's not very much state in this UI module. It's just a list of presenters and who's currently presenting. And it's really easy to do with Elm because whenever something changes, you need to regenerate the whole UI, and Elm does that automatically. It excels at this specific use case. And so it's much easier to write the UI in Elm. It's much easier to write the network communication in JavaScript or TypeScript. And you notice that by designing my component this way, I don't actually have to use the network. I can make a mock network, a service that just tests my UI and just throws in a few users and then takes out some users and then sets who's presenting, and then you can check that it actually works without ever relying on the other components in the system. So this is how we're trying to learn from backend developers, and this is how the JavaScript teams at Prezi are trying to build a really large application in JavaScript where we can use multiple languages and replace components one at a time. Thank you. Any questions? Thanks. If anyone has any questions or wants to talk to me later about what we're doing at Prezi, please come find me. Thanks.
Okay.